What's up, Math 8? If you didn't know already, this is Mr. Bainey, and we're going to study up a little bit before you have to take the Unit 4 test. That's Module 9 and 10, all about transformations. And so if you didn't try these problems yet, page 337, number 1 through 4, and page 339, number 1 and 2. So here we go. Number 1 on page 337, we're going to reflect over the x-axis. So we're going to take this triangle and we're going to flip it over the x-axis. The x-axis is the one going horizontally straight across. So it's going to look like this. B prime is going to be here, right on the other side of the x-axis. A prime will be here. And because point C is really far, point C is going to be way down here when you reflect it. And this is my image. Okay, some important properties you need to remember for this test is that when we do a reflection is going to end up with the same size and the same shape when you compare the image to the pre-image, but it's going to be a different orientation. Okay, I'm not going to write down all the properties, but this is something you need to think about when you're comparing the image to the pre-image. Number 2, translation 5 units to the right. So that means if I start at point C, I'm going to count 1, 2, 3, 4, and 5, and my C prime is going to be right there. So there's C prime. Do the same thing with B, 1, 2, 3, 4, and 5. And then point A as well, 1, 2, 3, 4, and 5. So I end up with this image. And the properties of a translation are that we have same size, same shape, and also same orientation. Really, the only thing different here is the location of the shape. Okay, number 3. We're going to take this same triangle, the pre-image, and rotate it 90 degrees counterclockwise about the origin. So counterclockwise means it's going to go into this section right over here, and everything is going to be turning, or at least the shape is going to be turning. So point C, if you think about the coordinates of point C, it's actually the coordinates -1, 5. And so you're going to end up switching those two numbers. So it's going to be a 5 and then a 1. And so you know that all the points down here are -x and -y. So if you know that's negative and negative, then if you swap these numbers, it's going to be a -5 and a -1. So it's going to be right here. There's my C prime. Okay, point B is going to end up right here. B prime, I mean. And then A prime is going to end up down here. And so this is my image. So it does actually look like it flipped, but the way we label these points, it's definitely not a flip, not a reflection. And then the last one is number 4. Another translation, but we're affecting our x and our y. We're going to translate 4 units to the right and 4 units down. So if I start from C, 1, 2, 3, 4, and 1, 2, 3, 4. C prime is here. B, 1, 2, 3, 4, and 1, 2, 3, 4 down is B prime. And then A, 1, 2, 3, 4, 1, 2, 3, and 4 is my A prime. So this is same size, same shape, and same orientation. I did forget to mention about number 3 that the image is the same size and same shape, but a different orientation. Okay, on page 339, let's do the first 2 problems here. One thing that I forgot to mention on the last 2 pages is that understand how the rules work. You'll be able to use that transformation cheat sheet with the rules there so that you don't have to memorize them. You just have to know how they work and how to apply them. Okay, so number 1, number 2 here actually gives us rules. So we're going to take these shapes and we're going to apply the rule, and the rules are actually dilations. So we're going to make the shape bigger or smaller. So this means, number 1, that the scale scale factor is 1/4. We're going to multiply everything by 1/4. So if z is the point, oh, look at this. This goes by 2's. So z is the point 4, 8. X is the point, let's see, -8, 4. And y is the point -4, -4. So we're going to divide all of those by 4, because that's the same thing as multiplying by 1/4. So when we do that, let's go in alphabetical order here. So if we do point x, then we end up with divide by 4. Right? So we're going to get -2 and 1. So if I get -2 and 1, it ends up right here. Remember, this goes by 2, so I have to go halfway in between. There's my x prime. Y divided by 4, so I get -1 and -1, so it's about right there. There's y prime. And then z divided by 4 becomes 1, 2. So 1, 2 is about here. And I get this little itty bitty triangle. So it changes, it is the same shape, but it's a different size. And so we actually call that, this wasn't mentioned too much, we call them similar shapes, similar figures, whereas before we called them congruent. If they're same size and same shape, it's congruent. If they are same shape but different size, it's called similar. And that's what dilations does. I forgot to write, our new vertices of the dilated figure is x prime. Remember, we got -2, 1. Y prime is -1, -1. And z prime is 1, 2. Okay, number 2. Scale factor is 2. We use k as a scale factor, so I'm going to be a little bit lazy here. K equals 2. So we're going to multiply everything by 2. Let's write down our coordinates. A is, this goes by 1s this time, so -1, 2. B is 2, 2. C is 3, -1. And D is 0, -1. So when you multiply everything by 2, let's just write down these coordinates first so I don't forget. A prime, when I multiply the -1, 2, multiply by 2, I get -2, 4. B prime is going to end up being 4, 4. C prime is 6, -2. And D prime is 0, -2. So when I plot these points, I'm going to get this shape. It's going to be a bigger shape. There's A prime, B prime, C prime, and D prime. So again, we got a shape that is the same as what we started with, except it is a different size. Okay, and that's all there is to it. We have 4 transformations. Remember, we got translations, reflections, rotations, and dilations. Good luck on the test. Have a wonderful day.